We're going to continue our look at functions and their properties. We're going to be looking at local and absolute extrema, symmetry, asymptotes, and end behavior. Local and absolute extrema of functions. What does extrema mean? Extrema has to do with the extremes, the highest point or the maximum and the lowest point or the minimum. For example, if we have a graph that looks like this, we have what are called local maximums and local minimums. This point right there, somewhere in here, is the local maximum. It's not the highest point on the whole graph. This graph continues on, but it is the highest point of this area. And we'll have a local minimum here. Again, not the lowest point on the graph, but the lowest point of this section. We could also have an absolute minimum or an absolute maximum. If we have a graph that looked like this, here we're going to have an absolute minimum. Let's look at an example, identifying local extrema. Let's decide whether f of x equals x to the fourth minus 7x squared plus 6x has any local maxima or minima. We're going to use our calculators on this one. So go ahead and pause the video, get out your calculators, and follow along with me on this. The first thing we want to do is put the equation in the calculator. We're going to go to the y equals button. And if you have an equation in there, we'll clear it out. We'll use this button here for our x. So we want x to the fourth minus, make sure you don't use the negative button on that one, 7x, and now this one we can use the squared button plus 6x. And we're going to graph it. We want to make our window a little bit bigger. Go to Window. Here our x minimum goes to -10, maximum is 10. So let's go to -20 on this one. See if that gets, oops, that was our x's. Didn't mean to do that. Let's try again. We'll leave our x minimum as -10. And that was the y we wanted to change at -20. And let's graph that. Still are not getting the minimum down there, so let's go make it -30. And graph. There we go. So on this equation we can see we have a local minimum here, a local maximum here, and a local minimum here. What we want to do now is find out what those values are. Again, we're going to let our calculator do the work. To find the maximum or the minimum, we're going to go to the Calc button. To get there, we go second and trace, which gets us to Calc. We want the minimum, which is 3. And then what we have to do is use the arrow keys. It's asking for the left bound. So we want to be left somewhere, anywhere left of that minimum, and hit enter. And then it asks for the right bound, so go use the arrow key, go anywhere to the right of that. The further away you are from it, the longer it will take to calculate. Then it asks for a guess. You don't need to put in a guess. That just helps speed it up a little bit, but if you just hit enter, it'll then calculate the answer. And here we have the minimum is y equals -24. So we have a local minimum here, -24.19. Find this local minimum. We would go second and the calc again. We want the minimum. Take the arrow keys. Take it to the left of that minimum. Hit enter. Arrow keys to the right. Hit enter and enter again for the guess, and we'll get another local minimum of -1.766. And finally, to get the maximum, we get second calc 4 for the maximum, arrow key over to left of the maximum, anywhere in there, enter, arrow key to the right, enter, enter for your guess, and there we have a maximum of 1.32. Now I'll give you a problem to try on your own. Find all the local maxima and minimum for g of x equals x to the third plus 4x minus 1. Next, we're going to look at symmetry. Begin by looking at symmetry with respect to the y-axis. For example, if we look at f of x equals x squared. Three different ways we can look at it. We can look at it graphically. We can see that it is symmetrical around the y-axis. We can look at it numerically. We see that the x's are symmetrical, -3, -2, 1, 1, 2, 3, and the f of x for the y value is 9, 4, 1, 1, 4, 9. And the final way we're going to do is look at it algebraically. And algebraically, we want to look at f of negative x and see if that equals f of x. So if we have our function f of x equals x squared, let's look at f of negative x. This would be negative x squared. Anytime you square a negative, this will equal x squared, which is f of x. So in this case, f of negative x is the same thing as f of x, and this is known as an even function. Symmetry with respect to the x-axis. If we look at x equals y squared, graphically looks like this. Numerically, we'll see the x is 9, 4, 1, 1, 4, 9, and the y is -3, -2, 1, 1, 2, 3. Again, symmetrical. And now we're going to look at it algebraically. Going back to the graph and what we talked about functions, because we have two y values for an x, this is not a function. So it is neither odd nor even. And the third kind of symmetry we're going to look at is a symmetry with respect to the origin. For example, f of x equals x to the third. Graphically, it'll look like this. It is symmetrical with respect to the origin, meaning we can flip it around the origin and we would end up with the same thing. Numerically, we have -8, -27, -8, 1, 1, 8, 27. It is symmetrical there. And in this case, if it's symmetrical with respect to the origin, and we take f of negative x, we'll take our f of x equals x to the third. And now when we look at f of negative x, we get negative x to the third. When you raise something to the third power and you have a negative, that's the same thing as negative x to the third, which is negative f of x. And this is an odd function. Try this one. Tell whether the following function is odd, even, or neither. Graph it on your calculator and try finding f of negative x. Our next topic is asymptotes. An asymptote is a line that a graph is closer and closer to but never touches. If we have a horizontal asymptote, it means we have our graph coming closer and closer to this line but never touching it. If we have a vertical asymptote, the line will get closer and closer to that line but never touch it. Those are vertical asymptotes or horizontal asymptotes. The way we write this for our horizontal asymptotes, when we have a line getting closer and closer, we have the limit as x is getting closer to infinity of this particular function equals, let's say this line is 3, that's our limit. If we're going toward the negative infinity, we could have the limit as x approaches negative infinity of that particular function could be 6. That would be if this line is 6 and we're coming up this way. That's for the horizontal asymptotes. For the vertical asymptotes, let's say we have this line is at x is equal to 2. So we would say that the limit as x approaches 2 of this function is infinity. So as we get closer and closer to 2, our f of x, or our y value, is getting bigger and bigger and approaching infinity. Let's look at an example here. Let's find the asymptotes of the graph of y equals x over x squared minus x minus 2. Now, in the denominator, remember in the denominator of a fraction, we can never have it equal to 0. So the first thing we have to do is to factor this. So we have x and x, factors of 2, 2 and 1. So when that's equal to 0, our graph is undefined. So x cannot be equal to 2, and x cannot be equal to 1. So those are going to be vertical asymptotes, and the graph will never touch those. The horizontal asymptote, when we have x on the top, what's going to happen is x gets bigger and bigger. We have an x on the top, we have x squared on the bottom. So the denominator is going to grow much, much faster, in fact, exponentially faster than the top. And so the graph is going to get closer and closer to 0. Let's look at this on our calculator. Graph our equation here. What we have to do is go to our y equals, clear out the equation we had, start with the numerator, which is our x, divided by. Then when we have a polynomial in the denominator, we have to put it all in parentheses. So we indicate that that's all in the denominator. So then we'll get x, use the x squared key, minus x minus, again, make sure you're not using the negative sign, 2, close your parentheses, graph it. And as we've talked before about graph or failure, we can see that these are not asymptotes, but that's the actual graph or failure. So x is not equal to 2 or negative 1, and x is going to, on the ends, is going to get closer and closer to 0, but never touch it. So graphing an equation can help a lot with finding asymptotes. Try this one. Find the horizontal and vertical asymptotes for f of x equals 4 over x squared plus 1. Put it on your calculator and see what you get. Last topic we want to look at is end behavior. And we'll bring the calculator back up to look at that. End behavior. On this last function we did, at the ends of the graph is going to get closer and closer to 0. As x goes to positive infinity, it gets to closer to 0. As x goes to negative infinity, it goes to 0. Let's put in another equation. Let's try y equals x to the third. And graphing that, we can see at the end behavior, as x gets to negative infinity, y will go to negative infinity. And as x goes to positive infinity, y goes to positive infinity. We're looking at what happens to the very end of the lines. Try this. Describe the end behavior for h of x. Put it into your calculator and see what graph does. And now, just for fun, Disney's latest movie. See you in class.